Good morning, guys. It's another fantastic day outside in Las Vegas and a great day to write some code. Welcome to the Code with Nate channel. This is our co-host for today, Toddy Boy, and we're gonna start drinking some coffee and get back to work. So I'm gonna switch over to the desktop view, and I want to give a quick rundown of what we've created so far in the last 3 episodes. So we had an episode for planning this sales pipeline project, which is going to track a sequence of stages of a mocked business's sales pipeline. For instance, we have, I need to minimize this. I don't want this. Placing an ad on Google Facebook ads. Prospect navigates to page with ad. So I want to be able to track the sales pipeline similar to how this is happening now, but this is mocked. If you watch now, it's going to go from 1 to 2 to 3 to 4, all checked. Prospect is taken to a landing page, and you can see details for each step as well, and that should help you debug some things in your sales pipeline. And then we also created a mock landing page, and that's here, and that's just here. Welcome to GadgetX's shop. Really, we should have this maybe there. Let's see if that works. I want this to be the index. Let's see. Yeah, okay. So this is just a simple landing page, basically, that we're going to say somebody came from a Facebook application and clicked on an ad, came to this landing page that says Buy GadgetX, and then you click GadgetX, Buy GadgetX, and you'd be taken to a payment form. So we just want to click, that falls into our sales pipeline at step 1, 2, 3. At this step right here, user clicks on buy order button. Because prior to that, the prospect being taken to the landing page would have happened. So then after that, we can see that they're going to fill out the personal details and everything. So what I want to do now is we've set up three projects actually. We've set up our landing page, we've set up our dashboard here, and we've also set up a backend that's meant for the processing of real-time data using Scala and Akka. So now I want to start processing events in this project, and prior to this we did a hello world, but I think we might just use this same app for now. I don't know if we need play for all this. We might though. Let's see, we're gonna have to manipulate JSON, which play comes ready to do. We're going to need to start a persistent connection with WebSockets to our client. So I think maybe we will start a new or use our existing play app that we started actually, if it works, and that was called Sellify Backend, and we will port the work that we did to get Akka streams working in the last episode to a play app. And then we'll get started on pushing events from our landing page to our dashboard. And we just want to make sure probably that everything is good here. 2.12.4, 2.12.6 is the Scala version here. We want 2.12.6 as well, probably. see how that works. We don't want this to be a Gradle project, really. I used to like Gradle a lot. I don't know, maybe it's still good, but I don't know. How do I stop Gradle? I want SBT to be our build system. Maybe if we delete this Gradle file. So when we created this play app, it came with a Gradle file. Okay, here's SBT. We need to delete all these Gradle files. Oh man. Delete. Just cleaning up some stuff here before we start working, because we want SBT exit to manage our project here. Let's see what kind of build tools we're using. Gradle. Okay, build tools. So for some reason it's using Gradle. I don't really know how to stop it from using Gradle though. Let's just let's start a new project. Last episode we had to update our IDE, IntelliJ, because it wasn't able to handle the most recent version of Scala. So we'll just start a fresh install, and that's kind of what this Hello World app that I was just showing you, why that came to be. We had to make that because Play wasn't working for us. We want to install it with SBT, that's right. We've got a number of sample projects. Where's the install command? First to the new application. Creating a new application using SBT. Yeah. Play Scala seed. That's what we want. So I'm going to go into, first of all, I'm going to get rid of that project we created before, so it doesn't waste any room on our disk. And then I'm going to make another project with a different name and run that SBT command that we just found in the documentation to create a new Play framework application. Alright. And we'll call this Selfie backend. com.code with Nate is the main package. Alright, so now we've got this project that's been created called Selfie backend and Selfie backend 2. We want to use auto import. We don't want to use Gradle. Let's see. Gradle JVM. I don't like that it starts with Gradle. No, it's not a Gradle project. See, it's not. It's trying to import from Gradle, and we don't want to do that. So what if we go in here and we remove build.gradle, Gradle and see if it imports from SBT now. I think last time that was our issue, is that we imported it as a Gradle app. Now it knows that it's an SBT project. It probably prioritizes the Gradle file over SBT, maybe even because of alphabetical order in the code base of IntelliJ. Let's see. Download. Yeah. We want to use the SBT shell for build and import. It makes things easier, in my opinion. Cool. Alright, so that's importing. So we had to go and clean up our Gradle file. I guess we can get rid of that too. Didn't see those there. Now everything looks good. I don't know what this G8 file is. Okay. So at the end of the last episode, we created this landing page, and with the landing page, we want to send. Oh, look, we already are. We're sending a post request to our server. So the landing page would be its own application, basically, with the server and the front end. And we would send the ByGadgetX event to the server, and now we need to send that ByGadgetX event to our dashboard, our analytics backend, which is going to do real-time processing stuff for us. So we are here in Solidify backend. Things are still building. We're going to need to add this dependency here, we know. I think in Akka as well. Maybe. We'll see. I think we'll first start by implementing the WebSocket connection from our sales pipeline dashboard to the Scala backend, probably. So let's see here. Okay, cool. Looks like we're all built out. We've got a controller, home controller. We are going to, and I guess we can go over the directory structure here really quick. So we've got app, which is the main source directory for Scala Play, this version. We've got controller, which are our front controllers, and they render, you can inject services using this inject tag here, and render templates as in each action, which is a front controller. The routes are configured in this configuration directory. Routes, this is some logging configuration. This is your main application configuration. We don't have anything special in here yet. This is all build stuff. We would put our assets in here and some tests in here. That's pretty much it. Scratches and consoles. This is new. Oh, that's cool. Okay, so we are going to start by creating a new controller, and we want to call this. We're going to call it. We're not going to be doing that either. We are going to be rendering JSON cool. So essentially we need to create a WebSocket connection because we want to see things real time. We could also use HTTP2, which is a newer technology. It's not supported on as many browsers, I think, but I do believe the support is pretty good now. Let's see what that looks like. HTTP2 browser support. because I want to use new technologies for this stuff. Can I use HTTP2? And it says we can use it for the current versions of everything except for Opera Mini and the UC browser for Android. What is the UC browser for Android? I don't even know what that is. Is that the default browser? Browser, Android. I don't know what it is. UC browser. Well, I think we're going to use HTTP2, and Android's just going to have to catch up. It looks like you can use Chrome for Android just fine. I don't know what UC is. I don't know if that's the default browser or what. Anyways, HTTP2 allows for, I believe, persistent connections similar to WebSockets. HTTP2 versus WebSockets. So yeah, so the server can push to our front end as well. The only thing is I don't want to have to set up SSL, and I wonder if we have to. Nowadays, complex web apps that feature rich dynamic UIs are taken for granted, and it's not surprising. The internet has come a long way since its inception. Initially, the internet wasn't built to support such dynamic and complex apps. Yep, blah, blah, blah. So now we can push and pull. So our server can push data just like WebSockets. Yeah, so WebSockets. I'm reading through to see if we want to use WebSockets or HTTP2 right now. Let's see. Well, HTTP2 has a lot to offer. It doesn't completely replace the need for existing push stream technologies. First important thing to notice about HTTP2 is that it's not a replacement for all of HTTP. Oh, the same as today. HTTP is about improving the efficiency of the way data is transferred on the wire. Now, if we compare HTTP2 to WebSocket, we see a lot of similarities. Client server and then server push. Yes. Okay, but prioritization, no. Binary or textual compressed. Server push, which enables the server to proactively send resources to the client cache, does not, however, allow for pushing data down to the client application itself. Server pushes are only processed by the browser and do not pop up in the application code, meaning there's no API for the application to get notifications for these events. The server that can then decide to send data whenever a new chunk of data is available. It's considered a one-way publish-subscribe model. It also offers a standard JavaScript API, client API named event source, implemented in most modern browsers. Can be easily polyfilled. Yeah, let's see what this implementation would look like. Sounds like WebSockets definitely has what we want, but, well, I've used WebSockets before, but I don't know how to use HTTP2. Let's see, what do we want? We want the push thing. Server-side events. HTTP2 server-side events is what we want. Instead of WebSockets for unidirectional data flow over HTTP2. Okay. When building a web application, one must consider what kind of delivery mechanism we're going to use. Now there's a few. Server-side events. Okay, I just want to do server-side events. Wow. There's a lot going on here. Server-side events. I just want an example. Server-side events example. Okay, so source would be an event source. And then on message. Wow, that looks really simple, huh? That looks really simple. Okay, So the HTTP client that we use needs to support server-side events. npm server-side events. Even though it looks like the default one is pretty good. So we might just work with this example. This is the interface now for receiving server-side events. So we want to make a connection. It looks like alright, so we're ready to go. So in our front end for our dashboard, and it's an Angular app for those of you just joining. Hello, by the way. Basically, we've got these events that come in that are mocked right now that represent a sales pipeline. So placing an ad on Google, Facebook ads, prospect navigates the page with ad, prospect sees ad. But now we want to do this real time using events. So we're going to use HTTP 2 to do this. And I think we want to do this inside of our controller. Maybe not floating out in here. And we're using TypeScript, which is something... I think we're using TypeScript because this is a new keyword for me, which is something I'm kind of unfamiliar with. So we'll have to see if this works. I don't know why this is complaining. Oh, okay, we needed to add the white space there. Should be open quote. Okay, so this checks to see if we have HTTP 2 in our browser, and then I guess to use HTTP 2 we just follow this example here. So I want console info HTTP 2 supported, and I like single quotes, I guess. And we will take that same message and just tweak it for not supported. And this is going to check, I guess, that endpoint. Oh no, it doesn't check the endpoint. So our server, let's run now our Scala Play app and see what happens. Except I want to add one endpoint to our sales pipeline event controller that returns JSON, I guess. Let's see. I guess we need to implement this on the back end, don't we? So we want to Google Scala Play server-side events and see what happens, right? Server sent events. Server sent, not server side. And that's going to allow us to do HTTP 2 in our application. Let's see. And I want something pretty recent because things change. Okay, here's an example. Akka server sent events support. Okay. So it looks like this is using Akka. So we define a route, path events. Interesting. So this is not using the standard Scala Play controllers that we're used to using. Looks like there's not a lot of docs, so we're kind of in the Wild West here. This is our best, I think, bet up here. Let's see what this alpaca library looks like. So to use it, I guess, simply define an event source by giving, oh, this is to connect as well. This is for the client side. We want to be a server. server sent event support. For pushing notifications from an HTTP server to a client. In contrast to WebSocket, which offers bidirectional communication, SSE only allows for one-way communication from the server to the client. If that's all you need, SSE has the advantages to be much simpler to rely on HTTP only, and to offer retry semantics on broken connections by the browser. Okay, with the media type text event stream, which has the fixed character encoding UTF-8 and keeps the response open to send events. Okay. In order to respond to an HTTP request with an event stream, you have to bring an implicit toResponse marshaller defined by event stream marshalling into scope, defining the respective route. Okay, so I guess we need to use this Akka HTTP setup, and then we can use this bit here. So let's take a look at Scala HTTP, or Scala Akka HTTP, and let's see, introduction using Akka HTTP. So we need to import these two libraries here. What is the latest version of Akka HTTP? I think we already have the latest version of Akka Stream. Maybe we don't though. We'll just use 2.5.11, so we're using the same version as the docs for now. And we need to import Akka HTTP and Akka Stream, and that's going to give us the ability to serve HTTP to requests using Akka HTTP. So this Akka HTTP thing is new to me. Okay, so to create a web server, okay, it looks like we create a new object and everything. We're not going to be using play to run this, maybe? I'm just reading through right now to see what these guys' implementations are. I don't even see. On the other hand, if you prefer to build your applications with the guidance of a framework, you should use Play Framework or a Legumetry. Interesting. Okay. Well, we'll just do it manually for now. And I think we'll stay out of the Play Framework for now, even. We'll go use that Akka Hello World project we created last episode, and because that's actually closer to what we have here, and this is a simpler example to figure out what's going on here. So we're going to create a new file. It's going to be an object, and it's going to be called sales pipeline web server, events web server. And we're going to paste that code we just copied in here. We're going to take that name of that object that got created by our IDE and replace the name of the object that we copy pasted in here. And you can see we're still pulling some assets from SBT, from the repos there, the source control repositories that host that code. And here we go. We've got, so in theory we should have a server here. So I'm going to go ahead and right click on our method and just run this and see if we do in fact have a server. And if we do, we can go ahead and implement this server sent events protocol in our server. Alright, so everything compiled, it looks like. Server online at 8080, and if we go there, it looks like if we hit the hello path, say hello to Akka HTTP. Alright, cool. Akka HTTP was easier to set up than Scala Play, so that's pretty cool. So we're going to go ahead now and implement our server sent event support for HTTP 2. And this is a simple example right here, it looks like. It's really easy, it looks like. So we're going to call, or we're going to create this route here. I think we need to import this source, and I don't know if we want Akka stream source. Do we have an import clause in here? Yeah, we do. We want Akka stream source. And we're going to need that duration. There's a few imports we need to make for this to work. Local time and server sent event, which we can import. ISO local time. That looks like, oh, it's coming from here. And that might be it. What else do we have here? Type mismatch. It doesn't like something, but this is a pretty complicated chunk of code, so let's take a minute to figure out what's going on here. So we're creating a path, and when we call get on this events endpoint, we want to, what is this, complete? Complete looks like it sends back the response to the client. Server sent heartbeat. Interesting. Okay. What's different from our example here? What if we define this like this, and we want to import that there. I want to see if this method compiles. Okay, it does. So I think what we need to do then is, let's see, we need to figure out how to handle multiple routes, I guess, or we can just, what we'll do is we'll comment out this initial route and do route equals get route, or just route. Sorry, this is events route. Events route, and now in theory we're going to have that route available to us. So let's stop then and run this again. And in our client code, we're going to try and connect to this and see if we get anything. And then we'll have hopefully successfully implemented HTTP 2, which will be a first for me, which would be cool. Okay, so we are running at 8080, and then /events is, let's just see if we can do this here in our browser. 8080/events, and look, stuff's coming in. Cool, that's awesome. Things work. Okay, so it looks like our backend is working just fine. Let's go ahead and implement that on our front end. So the endpoint looks like this, and then on message, sure, we can, let's console log each event, and let's also add to our HTML. Well, no, we're not going to do that. Let's just console log the event, and let's go ahead and open up our sales pipeline app now and see what happened. So it does look like HTTP 2 supported, it says. I wonder if we can only have one connection at any given time. I hope not. I don't think so. That wouldn't make any sense. But I'm not seeing our events here. It says failed to load. Oh, okay. So we need to add access control, allow origin, and things like that for cores to our requests. So I just want to see really quick Scala cores request headers. We need to be able to access this locally for now. Let's see if we have some examples of headers. Let's see. So right now our browser's complaining because we're making a request to localhost /3000 or whatever when we are when our browser is navigated to localhost 4200. So to the browser, that's a different domain, and it doesn't want us stealing data from our browser and sending it to that domain, or something, or vice versa. I don't know. So it's complaining about no access control allow origin header being present. So we're going to go ahead and add that header to our response here. Server sent event heartbeat. So let's see, how do we add headers to this? We need to figure out how to add headers to our responses here. But I don't know. Do we add them to the events themselves? No. We need to figure out how to do this in Akka Http. Adding headers Akka Http server. And then let's search for header and see headers, the package containing all that. Header model. I don't know that this is us. We're looking for the HTTP server. And we're looking for headers. It's not that. Server API. Respond with headers. That's what we want. So I'm kind of looking through. Respond with header. Interesting. That's how weird. With header exception handler. Respond with header. Okay, so what does that do? How many arguments does that take? It takes a response header. Okay. And we'll just do, we'll use this raw header. I just don't know where. This is a pretty strange syntax to me. But we'll see. We'll see if this works. It looks like the docs are telling us that this is what we need to do. And then we're going to add this header to our request with the value of star, which means that anybody can access this this server here. So we got to reboot our web server, and we will refresh this page, and we'll see if our header comes back. And it might have. I think actually our server blew up. Maybe it didn't. Oh, it did. Look, we see events. Yeah, right here, all our events are streaming in because we added that header. Cool, so now we have a persistent HTTP2 connection streaming events from our backend. Pretty neat. Alright, cool, that wasn't bad. Not bad at all. So now what I want to do, I want an event to come in real time from our landing page and then be piped out onto this to this dashboard that we've created here in real time. So let's think a minute about how to do that. Probably going to be doing some stuff that I've never done before, so that'll be fun. Okay, so we need to have an endpoint because I don't want my services to have to connect using HTTP2 or whatever. I want a plain HTTP request to come in from our server, our landing page server, and send that buy event, this buy gadget button. I want that button to send an event to its web server, and then its web server to send an HTTP request to our Scala application, and then I want that to log the event, and then to send it down, push it down the pipe using HTTP2 to our thing here. So that's what we're gonna do. So to send an event to our dashboard, we need to pipe an event to this source. So what we need is a source. There's a source sync. What types of sources are there? Scala sources. I don't think this has it. Sync. No. Akka streams. We need to learn about, there we go, working with graphs. So we have a sync and a flow and a source, right? No, maybe I don't know what I'm talking about. We'll just we'll figure it out. Okay, so we need a route that we need to have two routes, because now we've got this events route for the front end, but we also need a post. I'm wondering, can we call, I need to figure out how we can have two routes here. So let's take a look at the Akka HTTP server examples. Introduction, we want more than one route. Okay, cool, here we go, look at that. So this is how you have multiple routes, it looks like. And wow, this is the weirdest syntax. Okay, anyways, I think it's like that. Hey, that kind of worked, I think. So I want to see if we can post two events, and yeah, if we can post, that'd be great. So I'm gonna just put a, I don't know. We'll put some debugging with some breakpoints here and see if we can hit our breakpoints. Of course we need to run this in debug mode to do that. So we're going to debug, sales pipeline, events, web server, and we're going to shoot a message at it. Post, is it 3001? What port are we running on here? Okay, we already hit that, so 8080 is our port. 8080/events. Cool, okay, so that takes us, I believe, oh, that's wild. Yeah, I don't know how this is executing just yet, but it looks like we perform our action right here. So we need to create some kind of source that we can push events to, and then that source we want to reference here. So we want to create some kind of events source. And then we can subscribe to that here. Event source. event source. Okay, and that event source, yeah, it has server sent events. That's what we want, I guess. How about we map oh, that's interesting. So that's how you send the keep alive thing. And this is a string, right? Or yeah. Okay. So we should be able to still get our events, but we want to be able to post here and add an event to that event source. Let's see. I don't know how to do this. Add event to source Akka stream. Passing case classes to Akka streams source. Yeah, I don't know. What do we need to do here? So we have built, we've added this source, which is going to be sort of like our database in this instance. It's the persistent data that's going to be returned from our API. So let's just see that this works really quick, I guess. I don't know if maybe it will. Ideally, we should be able to subscribe to this from 2 different pages and see the same events at the same time. That's what I'm hoping for. Whoa, shouldn't have hit post. Okay, so we can see our events here on this instance of the page. Now let's open up a new one and a new page and see if we can see the same exact events coming in at the same time. That's going to be what we really want, but I'm not sure if that's, see, they're not quite the same time, are they? But are they the same values at least? 06049, it doesn't look like they are. 049, 049. They're not the same events. Or are they? No, I don't know. I don't think they are. Nope. So that's something we're going to have to address. They're not both getting the same events. I was expecting them to, because they're both subscribing to the same source. So that's a little weird. Janky. Alright, anyways, yeah, we really need to figure out how we can push events into a source. Push to a source, Akka stream. How to add elements to a source dynamically. There we go. This is what we want to do. One way, let's expand this. One way to have a non-finite source is to use a special kind of actor as the source, one that mixes in the actor publisher trait. If you create one of those actors and then wrap with a call to actor publisher apply, you end up with a reactive streams publisher instance, and with that you can use an apply from source to generate a source from it. After that, you just need to make sure your actor publisher class properly handles the reactive streams protocol for sending elements downstream, and you're good to go. A very trivial example. It says trivial, but it's like 40 lines long. Is here. So let's take a look at this example. So he's got some imports. So you have to initialize this actor system for Akka to work. This is a bunch of boilerplate stuff. And then you've got a source. Oh, this is the source. Okay. Source publish, run with sync. So that's going to take a publisher of integer and multiply it by 2. Actor ref, boom, I to string. Thread sleep. So it's going to sleep for 20. It's going to go for 20 seconds, it looks like. And then you've got, oh, this is the actor that it's talking about. Actor-based source. Okay, so this is the actor that we have to create. extends an actor with actor publisher, and it has items. And when we receive an item, items equals, okay, so see, it's a variable. So when we receive an item, we add it to our list of items. And when we request an item, if demand is greater than, sure. All right, we're going to implement this. Let's see what happens. Where do we want this? Where do we create our materializer here? In here. Okay, so I think we can define this down here. And let's see, val total demand. I don't know what total demand is. On next. Oh, okay. Maybe we just need to import these. And import actor publisher. And import these guys. And, okay. Okay, so supposedly this guy is good to go. It's an actor publisher of items of integer. Yeah, we'll see what happens here. I mean, we're getting somewhere. So we've got this actor that can now receive items, and we can create a source from that actor, supposedly. Oh, so we publish, I don't know, let's copy this bit here. So this is going to be done at the top of our web server. Where is that? So this event source, we're going to replace eventually with this thing here. Oh, wait a second. What's going on here? Props. What is this? Cannot resolve symbol 2 or times? Pub. Okay, why isn't that working? Publisher event should work, right? Source from publisher pub. Do we need to call .net? Oh, we do. Okay. And then sync we need to import. Okay, so now that doesn't work either, huh? That should though. I think we need dot run with Akka stream Scala DSL sync. Okay, so now we have our publisher run with sync for each print line. So this is going to, this is the sync, right? I don't know, where do we publish to this thing though? When we receive, what does this operator do here? Sends a one-way asynchronous message. Okay, so that's gonna send to our actor something. So this is what we would use to send an event to our actor. Let's see what happens when we run this example. I just want to see it compile and see some output. It looks like we should see print line for 2, 4, 6, 8, all the way to 40, if I'm reading this right. Hey, look, it does. That's cool. Okay, and then we should, now I want to be able to push to this from our web server. Okay, so this has a main. Can we take all this out of main and declare it up here? We should be able to with no problem, I would think. Yep. And now, when we hit our post to events, we can call this right here. And this is going to push that event to our thing here. So when we complete, we are going to push, we're going to push woo an event to our actor that we're subscribed to. Okay, and let's give that a shot and just see. Oh, it says 8080 is already being used. It's not good. We've lost something here. Oh, is it debug? Yeah, it's running on debug. Okay, so let's get rid of that whole thread sleep thing, because we don't really... We can do that a couple times or whatever. But we don't need it 20 times. Let's just do it 6 times. Let's say this is a mock example of us booting up our application. Alright, yeah, that sounds good. So let's run it. Kind of like using Scala better with outplay. It's a lot easier to iterate. It's pretty fun. Okay, so server online at 8080. Now, I expect that if we curl a post request to /events, we should see woo and event come out right here. So let's do that. Curl. So I did it. Uh-oh. We don't see. Oh, for input string. Oh, it's supposed to be a number, huh? Okay, so it mostly worked. It did mostly work. What is this? Oh, it needs to be an integer. Okay, yeah, that's not gonna work. Obviously, we need. But for now, just to prove the concept, 77 we'll use, and just see if this works. I just want to see that our pushing into this actor will trigger a print line here. So it's going to go 2468, blah, blah, blah. And then the server comes online. And then we post. Oh, look at that. Got other 77. But it didn't. Did it publish? So we don't see 77. It says got other. Got other. Case request. Oh, it's supposed to be a string though. What the heck? I don't know. What we really want this to be is a JSON object. Do we have that? Yes, we do. Right? No. So let's import Scala play JSON. I think we're pretty much working. Let's get it working with strings first, and then we'll switch over to objects. So we don't want integers. We want strings. Nope, we don't want that. Oh, that's why it couldn't add the item, because it wasn't an integer. Okay, cool. We want strings. And let's see here. So when we're pushing, yeah, this should work now. And then adding woo and now we're gonna do the request body. Let's how do we get the request from this? Akka HTTP request post. I want to figure out how we get the request body, because we are going to put the request body into our thing. Post. This is not the server. HTTP server. We were looking at the docs for the HTTP client. We want server. Route check. Response as string. This is a post request. Handling request body Akka Http. Route post entity as a person. Okay. Okay. Interesting. Entity as person. So it looks like maybe and of course we don't have that. Person should be a string now. Yes. But really it's event. So our events string. So I think this is gonna post this is gonna get the body as a string, supposedly. We'll see. And then it's gonna add that to the actor ref. So let's set up a request here with the body hello from Zish. Server's online. We punch that in. We did something wrong. Right? If we remove this bit, is it gonna work? We really need to get this. Need to figure out how to get that request body. Got other cancel. Oh, whoops, we didn't wait long enough. Whew. Don't know what that's all about. We didn't see our events. Maybe we saw a new line. Nope. Cancel. Why did we get a cancel? System terminate, it says. Okay, well, I don't know. So we were getting something. Oh, it does return event source. Okay, so it's pushing to that actor ref. It should be. But it's saying that it got canceled instead. So let's see what happens here. In theory, we should be hitting this case S string. So I want to see what happens. Let's send that post. And we do receive the string, and we even received the correct string. Okay. On next. Where does this on next? Okay. On next passes that down. It looks like if total demand equals 0. Oh, so it either adds it to the items or it calls on next. Okay, cool. That's okay. Data to do. So it got some data. I don't know. Okay, so the only other weirdness, I guess. Let's add this here. I think it might actually be working, but we're losing our events. The other thing I want to see is this working here? I I want to see if event is equal to the string of the request body. Alright, so what we need to do is we need to open up our browser to this page, or we can use this console logging that we've set up here. Okay, so where are we here? What do we have? Okay, nothing. It's just nothing's happened yet. Okay, so when we open up this, we should see in our console some events start streaming, and they do a little more frequently than I'd like, probably. Oh, and it's still streaming the wrong event source. We don't want this one. We want this source, and we don't want to run it with anything, I don't think. Let's just annotate the type. Source of integer. Publisher should be an active publisher of string, and we're not going to map that to anything. So now our event source is going to be now it's not good enough. What was this? What was this? Oh, we were mapping it to, if we look at this old source, which is not using the live data, we are mapping it to a server sent event here. So we need to do that probably. Map server sent event dot apply. No, that doesn't work. Let's see, X should be a string, right? Server sent events X. Expression, oh, that's because this should be server sent event. And I think we need this keep alive thing, maybe. We'll see. I don't know. Alright, let's refresh that now. And I'm interested to see if our events start streaming in again without us doing anything. Let's pause this. Does this go back and connect again? Well, it can't connect now because we start our server after we start those events. It says okay now. That's weird. So it says okay, but it's not okay. So we're not seeing the body. Okay, this is different. I mean, we're seeing new things. The events are coming down. Is it coming down as a WebSocket? How do we see HTTP2 events? I don't know. Do we have login for that in Google Chrome yet? Maybe not. So what oh man, this is weird. So, event source old. We don't want that anymore. Event source is happening here. Oh man. Where's that thread.sleep stuff happening? I don't think. We don't want this to happen until after our request. And then we want this stuff happening after the server completes, after it's done. Okay. So we'll call binding future on complete, maybe, or whatever. I don't know. We're kind of just trying stuff at this point to see what works. Don't know how any of this stuff really works. This is all new to me. Okay, so let's refresh. See if we're getting some events. We're definitely maybe getting events. All right, so I don't know what all this is. Let's try pushing event to our stream here. Says connection reset. So something has gone terribly wrong. And we don't know what. So we have the source. What happens if we curl and we just get it? Doesn't work. Connection reset by peer. Oh, look, okay. 8080. That's weird. It doesn't work anymore. I'm gonna back out of this a little bit, I think. I think it might be an issue with our event source here. What does this look like? Oh, it says cancelable. Source tick not used. Server sent event. I wonder if this also does not have cancelable, which is interesting. Let's see if our event source old still works. I want to see that our server's working. It looks like, I don't really know. The source that we created from that actor doesn't really play nicely with our HTTP2 event source implementation. Yeah, okay, so the old event source works just fine. No problems there. But the new one doesn't. Let's try that post again. And our event is correct. Hello from Zish. We complete with our event source. Yeah, it's getting everything just fine. And oh, hello from Zish came back. Okay. All right, so something is working right. I think the weirdness happens maybe in the beginning. I don't know. Let's see what the heck is happening here. All right, we're gonna refresh. We're very close to having real time events come in to our. Maybe I need to get rid of these breakpoints. To our dashboard. So that's kind of cool. Let's refresh here, and we should see. All right, so stuff is coming in. Look, we see numbers. That's right. And now we just see the heartbeat happening. That's what we wanted to see. Now let's post. If we post, we should see. Hello from Zish. Look at that. We got a live event, guys. We got a live event, and we should be able to post more. If I didn't have these freaking breakpoints set, we could really see it. Oh yeah, look at that. Look at how fast it comes in. That's going, oh yeah. That's coming from the terminal and being piped into our backend to this application here that's running in the console, our sales pipeline dashboard. And then that backend is piping the message through to our front end, this Angular app, and then being logged out right there. We're doing big things, guys. Very nice. Cool. I'm pretty excited about this. So the goal was today to actually send an event from our, not from Zish, this bash terminal that I'm using, but instead from our landing page application. So let's go implement that now. And that shouldn't take hardly any time at all, I think, because it's just a regular post request. So I'm going to copy this request we have here and navigate back to our landing page, which is really simple. And we're going to head to the code base here. This is our dashboard front end. On another tab, I have the landing page front end. So when we buy the gadget, what I want to do is make an HTTP request to a post request to events. So let's grab a request library. We want the request promises native library. So we're in the landing page directory here, and I'm going to run npm install save request promises -native, and of course that doesn't work. Let's see, what is it called? Request promises native. I thought that's what it was called. Oh, there's no S. Request promise native. And that's going to allow us to send a post request. How do we use it? Go through the migration upstream. Okay. Request. Post. I want post. Okay, here we go. This is how we post some data here. So we're going to post this data up to our API as part of this by gadget endpoint. Post, and that is running on localhost. Oh, we copied it actually here. This is the endpoint we want to hit. We're going to put the protocol in front of it. Post body is going to say, we're going to send an event, and for now, no. I don't know. We're going to send JSON.stringify. We're going to send our event as a JSON message, and that message is going to include the event's name, which is going to be client purchased, client clicked by, and then we'll send some other things which we're not going to use just yet, but we'll have like a product ID, which will be 1 to 3, and maybe the client ID. No, prospect is what we're calling him because he hasn't bought yet. Prospect ID. And that's going to be ABC. And then we need to set headers. Otherwise this request might not work. We need content type application JSON. And oh, look at that, that's interesting. Okay, cool. Automatically stringifies, so we don't need that. And we probably don't need that. Okay, I should have read what I copied and pasted into my thing first. So let's see, console log parse body, and then console.error are errors. And then we want to send, so we want to send purchased after we succeed, and then we'll say failed if we did not succeed. We need to import blah from blah. I want to set the language level to ECMAScript 6 so my browser's not complaining. Okay, so yeah, we're gonna send purchased or failed. I don't know how to fail. Okay, and then we're gonna refresh this, and we're gonna click buy, and we're gonna watch the console to see what's happening here. Buy gadget did not work. It says 500 internal error, so we're gonna have to go back and fix that. RP is not defined. We need to import that. Request promises. Well, what they're doing is they're calling it RP equals require request promises native, and that might work now. Cannot find module request. So it looks like we need to install, as a result of, or as a requirement of installing request promises native, we need to install and save request. because that's kind of the parent library. Request promises native depends on request. Now we're going to run our application again, and hopefully by now works. And we did get failed, so it didn't work. What did we get? 406. Resource representation is only available for these types. Text event stream. Okay. So we need to look into how to do Akka HTTP handle JSON, I believe. Marshalling and unmarshalling, yes, as order. Okay. So, okay, we need to read these docs, unfortunately, because I don't know what I'm doing. Akka's HTTP's marshalling and unmarshalling infrastructure makes it rather easy to seamlessly convert application domain objects from and to JSON. We want to convert it from JSON in this case, and then probably to and then to a string. Integration with Spray JSON is provided out of the box through the Akka HTTP Spray JSON module. Integration with other JSON libraries are supported by the community. See the list. So it looks like we probably want that Spray one since it's the only one that's officially supported by Akka. Spray JSON support provides a from entity unmarshaller and a to entity marshaller for every type T that an implicit Spray JSON root JSON reader and or root JSON writer respectively is available for. To enable automatic support for unmarshalling from and to JSON with Spray JSON, add a library dependency on to. I don't think that's proper English, but maybe it is. I'm not good with English either. Let's see. Boom. So we added this Akka HTTP Spray JSON, and next we need to provide a root JSON format for your type and bring it into scope. Okay, so we want to create a Scala case class that represents this event here. Okay, so that we're going to copy that over. We are looking for this guy and hit our web server. We're just going to create a case class up here called sales pipeline events. Everything is really coming together now. So sales pipeline event is going to have a body. Hold on, what does that look like again? I copied it over so we could use it. It has a body, which is a string, and a product ID, which is an integer. Really, it's going to be an optional, so I hope that it has optional values, but it might not. And we might have to create different types of events for each event we have. I don't know. And then prospect ID, which is a string. Okay. And now it wants us to collect your JSON format instances into a support trait. All right. Interesting. This is a neat way to do this, I guess. We need to import this and this, of course. And we only have this one type for now. And we're going to call it sales pipeline event format and annotate it since it's a public value here. The only thing, oh, it needs to be a final case class, maybe? Final. Why is it complaining here? Actual. Maybe 3. I'm wondering what this is. Why would this be called 2 and this be called 1? I think it's because of the number of arguments these classes have. Root JSON format doesn't conform to expected type. Oh, sales pipeline event. Yeah, I'm pretty sure this number is because of the number of arguments. Yeah, almost certainly. Okay, so now we need to extend that JSON support. Can we do that in an object? I don't know. JSON support. Hey, looks like we can. Looks like objects can extend traits. Okay, so now we can do entity as, instead of string, we can do sales pipeline event. And we can now return our sales pipeline event, supposedly. Oh, that's weird. Okay, how do we change that to a string now? Or do we want to? Maybe we don't want to. Yeah, let's see if we can make this source now, or our actor, handle, instead of a string, a sales pipeline event. Yeah, that'd be cool if that worked. And then, so we're not going to do this anymore. This was just to really to show off that this event source was working. Event source old we don't use anymore either. Can we fix all these, please? Oh my gosh, that's taking way longer than it should. Okay, so now we've got sales pipeline event here. An event source of sales pipeline event, ideally. Publisher of sales pipeline events. Okay, so the one thing is that it looks like server sent event. What does this take here? So it looks like we need to convert this to a string. So we need to call oh, is that how you do it? Response as string, maybe? Let's see what we can do. What does X have? X is a sales pipeline event. Okay, we need to figure out how we use spray transform class into string, or serialize, I guess, would be what we want. Let's see what happens if we call, no, X does not have a toString event, string. We'll see what happens if we call it toString there. So this event source, it only takes strings, it looks like, which is okay for our purposes here. Let's run this again. I'm not fully expecting this to work. If it does, that's going to be really cool. No, I don't know. Alright, so we are connected. It doesn't seem to be doing too well though. Address is already in use, it says. Where is it in use? I don't know. Let's run that again. Oh man, so we've got like a rogue server. We need, this address is being used by something. I think. Or just we messed something up. I think we messed something up maybe by extending this trait. It's like when we make a request, Okay, so somewhere this is running. Oh, it's running in debug mode over here. Okay, there we go. So we do want this running on 8080, not 8081. So I hope, guys, if you're enjoying the channel, I hope you can leave some feedback so that I can make the channel even better. Or if you've got some suggestions on ways that things can change, that is always cool. So let's see. So I think if we, ideally, if we hit this now, this back end, it says it failed. Okay, so got other cancel, it says. Resource representation is only available with these types. Okay. It's only available with these types. Event stream. Let's try and not send JSON, instead send a string representation of that JSON. Let's see what happens. So that was the error we were seeing from our server. What does it say now? The request's content type is not supported. We only support application JSON. So we're going to add the headers, and we're going to set content type equal to application JSON. And now we've got our app running again. Let's send a request. And did we get success? No. We have another error. Malformed. Object is missing required member body. Okay, that's good. And is that because we... Okay, that's because we did this wrong. This is how things look. It's actually an event name, a product ID, and a prospect ID. So let's restart. But it looks like we're very close. So it tried to marshal our request into that case class object. Ooh, this is looking good. Things might have happened here. Is this for a thing? No. Okay, we're close here. I want to run this in debug mode, and I want to see if this comes in correctly or not. So we're gonna go to our ByGadgetX. We're gonna send this. Oh, it says, oh, this one purchased though. I think maybe that thing wasn't running yet. No, it's failing. Hey. Yes, I am shooting a video. Okay. Why is it not? Object is missing the required member body, it says. Let's refresh our server. What's going on here? Failed, it says. What is the error? Econ reset. Okay. It's not liking something. We've got some kind of error happening, and we don't know what it is, and that is no good. So I'm trying to debug whatever's going on. We'll just replay that. So our event is coming in just fine, so that's good. And then we're pushing to our actor. I think we should be pushing. It says complete. Yep. Our events got pushed in. That's fine. On next is getting called now. So it might be an issue with this. I think this toString might not be working. So that last one, it says, I think it succeeded. I think maybe we're not responding to our, we probably need to respond. Okay, so we're sending our event source here. What if we just sent, how do I respond to an Akka HTTP? HTTP server get Akka. Web server, here we go. So we want to just complete. We want to complete with thanks. Can we complete with string? Success or whatever. I don't know. I think everything is working except for subscribing to our event source is not working. But I'm not entirely sure. I want to refresh this web server because I don't want tainted logs. Okay, and we'll refresh this. By GadgetX. Sorry, events coming in. It's being passed to our actor, which is receiving the item. And we got back purchased. But we don't see anything after that. So I want to see what happens when we do print line got plus s2 string. Let's see what that looks like. Is toString gonna work? I don't know. I don't know if it will. Takes a sweet time to start up, doesn't it? By GadgetX, we come in. Yep, gets pushed down the pipe, and we should see. So got sales pipeline event. Okay, so that's a string. Okay. On next, right? Receive, yeah. And then we want to see. I want to see this. So now we do create a server sent event. But it's not. Doesn't work anymore. Is something wrong with our front end? No, eventually this okay thing doesn't work. So if we restart this and we clear out our console, once our server starts, okay, does it immediately not work? Yeah. Or is that just keep alive? Let's see. What happens if we just say keep alive? Do we need to refresh our app? So we're receiving the events just fine. Now it's just a matter of piping those events into our as an event. Okay, keep alive's working, and then as soon as we go here and click by GadgetX, maybe the debugger's messing things up. It says we purchased it. Oh look, it came down. I don't know what happened, but it's there now, isn't it? Let's see if we can do more. By GadgetX. Oh, there's another one. Let's send like several. Wow. Guys, we did it. We've done it. Congratulations. Feels good, man. So check it out. So our sales pipeline now receives, well, it receives these keep alive events, which are pretty annoying. So we're gonna get rid of those. But it also, as soon as we, can we filter out keep alive? No, yeah. Sales. So check this out. So as soon as we click by GadgetX on our landing page, boom. Wait, there we go. Okay, I had to click into the page first. It's almost immediate. It is immediate. I don't see any latency. You guys might, but as standing right here, I don't see any latency in between our landing page and our sales pipeline dashboard. So, man, I'm thrilled with the results here. This is cool. This is the coolest thing I've built in a while. So this is exciting, guys. I can't wait to work on this more. So for those of you joining, I'm going to give a quick roundup of what we've done this episode and then probably close out for today. What we've done is we've built this sales pipeline monitoring dashboard where events come in real time, and you can see, so a prospect, or so we placed an ad on Google Ads, and then somebody sees that ad, and then they click on the ad, they are taken to our landing page, which we created a mock landing page, and then the user clicks the buy order button. So all these events we are going to be sending to this dashboard real time. Right now, this is mocked out. That was fakely checked, each of those boxes. But soon, we are going to send all those events in real time as we place ads and things. Right now, we've created this fake landing page, which sends an event to our front end using Akka streams, the Akka streams HTTP libraries. So if I click buy gadget, I get an event right here in real time. So let me just clear that out. Buy gadget, buy gadget, buy gadget. Maybe we become disconnected or something, I don't know. That didn't actually work, but are we getting responses purchased? That's weird. It does seem to, I wonder if multiple subscribers messes with it or something. I don't know. We're gonna have to look into that, but shows up real time. Yeah, what is the deal with that? So we should be seeing heartbeat here. I don't know. That's pretty weird. Anyways, our events come in real time. It's pretty cool. So thanks for watching, guys. Always appreciate support. Next time, we are going to probably add some more data to this event. Like, we're going to track user sessions across our different events and pipe those in. We're also going to be implementing Elasticsearch to store our events so that we can build some pretty cool reporting, like historic reporting, and that Elasticsearch will be the source of truth for some more dashboards that we're going to create. And we'll probably clean this stuff up a little bit. So thanks for watching, guys. As always, have a great day, and happy coding.